Good afternoon, good morning, and even good evening. A massive thank you to all of you for joining us here today at the Future of Protein Production. My name is Nick Bradley, and I will be your host for the next hour or so. Just a quick rundown of who we are. We are an information platform that connects companies in the alternative proteins value chain. We do this via daily news, weekly emailers, these monthly webinars, podcasts, and our quarterly magazine, Protein Production Technology International. We also organise virtual and in-person events. And on that note, we hope to meet many of you face-to-face on the 11th and 12th of October when we hold our Future Protein Production live conference and exhibition at RAI Amsterdam in the Netherlands. It would be fantastic to see some of you there later in the year. Now on to today, the topic being extracting proteins from waste. We have a fantastic panel for you, a diverse set of speakers with expertise in insect proteins, fungi and fermentation, the upcycling of brewers' spent grains, and we even have an investment expert who can help us assess the relevance and impact of these upcycling innovators. There are, of course, various factors at play here. There's food waste, there's global hunger and malnutrition, there's the protein gap, plus we can all agree that we generally need more sustainable and ethical ways of producing proteins. If alternative proteins are the answer, then proteins derived from waste are surely the ultimate solution. Here in the UK alone, 1.5 million tonnes of organic waste are created from the production of food, such as meat, dairy, fruit, and brewing products. Globally, though, around 931 million tonnes of food goes to waste annually. That's almost 1 billion tonnes a year. Now, you may have seen it, but there was a study from King's College London recently that suggested transforming food waste using sustainable technologies could produce enough protein to tackle the global food crisis. Two of those technology options, fermentation and using insects, are represented on our panel today. And let's not forget that food waste and loss causes about 10% of the emissions driving the climate emergency. In fact, for each kilo of food protein wasted, between 15 and 750 kilos of CO2 end up in the atmosphere. In fact, if food waste were a country, it would have the third highest emissions after only the USA and China. Now, we're never going to become a waste-free society, but we can do something with at least some of that waste, adopting the principles of a circular economy in food. As far as hunger and malnutrition goes, the number of people facing or at risk of acute food insecurity increased from 135 million in 53 countries pre-pandemic to 345 million in 82 countries today. Around 3 billion people are likely to face food insecurity due to the current economic and geopolitical climate, a number that can only be expected to increase as climate change accelerates. As we know, alternative proteins can help plug that protein gap, but implementing them is not without its challenges. Arguably, it's even tougher for alternative proteins produced using valorization. By 2050, the world population is projected to reach 10 billion people. That growth requires food production to increase by approximately 70%. Demand for protein is set to increase accordingly. We need to first understand that all sources of protein, animal and plant-based, as well as single-cell protein, play an equally important role. So today, we will discuss how food waste can be efficiently valorized, not only by reintroduction into the food supply chain, but also as a template for the development of sustainable technologies by allowing it to exit the food value chain. In doing so, alleviating some of the most urgent global challenges. Some of the stats I've already cited show that we are at critical crossroads. We need to rise to the challenge of meeting people's immediate food needs, while at the same time supporting programs that build long-term resilience. The alternative is hunger on a catastrophic scale. However, as we will learn today, it is in our power to sustainably overcome that gap. Before we begin, I wanted to let you know that you can submit questions via the Q&A box under the Engage button on the right-hand side of your screen. There will be a bit of time at the end for our participants to answer your questions, and I will do my best to get through as many of them as possible. So time now to welcome our panelists for today. Before we come to each of you individually to get into the nitty-gritty of what you're doing, how you're doing it, and the end product, I just wanted to quickly get an overview of why you think we need alternative proteins as part of a sustainable global food system, but more specifically, proteins that are derived from waste products. So before each of you introduces yourself, I just wanted to know what the main drivers are for you in focusing on waste to protein technologies. Tyler, you're in the investment community, so could probably start us off as you're working with various different players in all different fields.
Sure. Yeah, so I've been investing in upcycled food since about 2016, after first learning about the impact of food waste and a large amount of food waste. And so I've invested in companies like Renewal Mill, Blue Stripes Cacao, and Atomo Coffee. But that's actually how I met the Beyond Impact team and Claire Smith, who started Beyond Impact. We were both angel investors in Renewal Mill at the time. And now the fund has invested in Renewal Mill. So we are very keen on food waste. Beyond Impact, just a bit about Beyond Impact. We invest in companies taking animals out of the supply chain of food, beauty, and materials, primarily from a climate impact standpoint. And so we've been researching this space. We really like the idea of creating alternative proteins from food waste. And it's happening in several different subcategories that we can talk about later.
Working in this waste to protein space.
Pardon? I missed all your question.
Sorry, I was coming to Natalie there for...
Oh, sorry.
Is she on screen? There she is. Natalie, if you could just quickly introduce yourself and your company and then explain what your main driver is for working in this space.
Yes, hello. So my name is Natalie. I have a background as chemical engineer with a PhD in biotechnology. After that, I spent almost 10 years working in the field of plastic in Belgium. When I came back to France, and I worked for 5 years in a company called Insect, working with mealworms that are consuming leftovers of cereal production. When I moved to Sweden, where I opened my own company, Norbite, working with wax moth, which is able to digest plastic waste to transform it to proteins. And recently, I have joined also FlyFeed, a company which is working in Vietnam to transform organic waste into proteins by using black soldier fly. So basically, 3 different companies with 3 different insects transforming different types of waste into proteins.
Excellent. And Stefan, if we can get him on screen. Fantastic. Stefan, what's your driver?
Yeah, thanks Nick, for having me. Because I think you gave all the good reasons already in your little speech at the beginning. For me, it's like having food that is available already in the first place, and we're not currently fully utilizing it for its full potential, while we produce so much else, all the time with a less profitable or beneficial sort of like impact to the world. I think it's just a big motivator for me to be in the space and to see what we can do with upcycling, because food waste, especially when we look at, let's say, the developed countries, is a huge problem in our societies. And I think there's much more we can do to make sure that we minimize that waste and utilize everything to its fullest extent. So the company that I'm working for in the meantime is called Evergreen Ingredients. We're making protein from brewer spent grains, as you mentioned a bit in the beginning. So I think that explains also the connection to turning something that is currently used not to its fullest potential and extracting valuable components for human nutrition out of it. And I'm looking after the technology side. So everything from operations to R&D, and I can explain this out.
Brilliant. Okay, well, we'll come back to you in a minute with a few more specific questions. And now, Rami,
Hi.
you're over there in Colombia.
Yeah, I'm from Colombia. My name is Rami Jada, and I was born in California, but grew up in Cuba in the 90s. So one day I heard a kid ask his mom why there was no food in the fridge. And when I asked mine how that was possible, she cried, and I cried in confusion. And 2 vague concepts got embedded in my mind. And it was like, how was it possible that with the distribution channels that I have seen in other countries, there was food available in supermarkets late at night, and at the same time there was like hunger, like physical, literal hunger. So another thing came up to my mind, which was it's probably because food production itself is inefficient. I mean, from 10,000 years ago, when mankind adopted agriculture, we barely harvest 10% of those calories in the form of the vegetables or fruits. So that is how I started, or why I got interested in upcycling food waste.
Brilliant. Okay, we're going to spend a few minutes with each of you individually now. So first of all, we're going to have Stefan. I mean, you mentioned it before. The brewing industry generates around 9 million metric tons of dry spent barley grain every year, and that's typically relegated to animal feed or landfill. Now, the beer brewing process removes starch from barley, leaving behind, I think, what you guys call the golden remainder. So you're effectively turning what was once previously sold as a low-value animal feed into a sustainable source of protein. So you're putting that to good use at Evergreen Ingredients.
Yeah, absolutely. I think, when you look at the composition of brewer spent grain, it's mostly composed of fibers, proteins, some fat, and then in the fact, since it's mostly sold wet, it's actually water. But all of these are valuable nutrients that today we have available in abundance around the globe. And at Evergreen, like you said, we said, okay, we need to do something more to it than what we do, selling it through, let's say, cattle feed. And that's the whole essence of why Evergreen was started in the first place.
Now, AB InBev is one of the largest brewing companies in the world. Brands such as Budweiser, Stella Artois, Corona, I'm familiar with them, to name just a few. Could you tell us a little bit about how Evergreen came about and the relationship with AB InBev?
Yeah, no, happy. So we are fully part of AB InBev, and we originated from ZX Venture, which is the venture for arm basically from the company that was looking at new technologies to disrupt the space, and hence also made an investment here in this let's say alternative protein area. And Evergreen or AB InBev has always been behind and invested in sustainability. So there's a 100+ accelerator, for example, that we have been part of, where we partner with other FMCG companies to really tackle some of the big challenges out there. And so that is the relationship that we have currently. Obviously, it's beneficial to be part of a big company like this that has such an abundance of feedstock, mostly in every geographical area of the world. But because we produce a food ingredient, fundamental different business model than making and selling beer, we act quite independently eventually from each other.
Oh, I'm going to come on to that supply chain in a moment. Are you able to tell us anything about the process itself? I mean, is it complicated, expensive? What about scales that you're achieving?
Yeah, absolutely. I mean, it's all relative, of course, whether you consider it being complicated or not. I think if you look at, when I ask my scientists, they would say it's absolutely unbelievably complicated. In the end, we've been able to take unit operations that exist today and piece them together to create what we want to create in the end. Scale is what matters the most. So I missed to say that in the beginning, but what drives me always is to create something that eventually can have a large scale impact, because I think that's what we need to really drive the needle eventually on the sustainability piece. And our facility in St. Louis now is able to make 7,000 tons roughly of protein isolate, which is a not, ginormous, but it's a very significant scale to enter into the market, to see, what kind of demand there, and then expand further into other geographies.
And what about the final ingredient, the types of applications that you're targeting? Are you looking to use the final products in applications within the AB InBev portfolio, or are you selling it to other brands and manufacturers?
Yeah, primarily selling it to other brands. So primarily we are a B2B ingredient business that is, open to everyone that is considering to add it. There's, of course, eventually the opportunity that some of our portfolios within ABI may use some of the ingredient, but at first it's not the idea. When you look at where protein is used today traditionally in protein shakes, in baked applications, we always like to say that our protein is the ultimate beverage protein. So it's really great because of solubility going into a protein shake or an RTD beverage.
I mean, you talked about sustainability before. From a sustainability standpoint, through upcycling, you're actually using all of the land that you already have. So that's a big win over other protein sources such as pea or soy, for instance.
Yeah, absolutely. I mean, we did quite an extensive LCA analysis that we then also challenged with some NGO companies afterwards, and there's great benefits working with a byproduct in the first place. One of the things, of course, that we also looked at is water consumption. And when we designed the process, we paid special attention to, for example, installing a reverse osmosis system that allows us merely to use all of the water in our supply chain. Because of most of our breweries are actually currently carbon neutral from an energy point of view, we also benefit there in terms of the electricity use. So outside of land use, which is maybe the obvious one, there's definitely lots of other benefits still on the other angles.
Yeah. And am I right in thinking that because you're working with barley, you don't need to go through any sort of rigmarole of regulatory clearances in terms of novel proteins, for instance, in the EU?
Yeah, it really depends from market to market. In the end, we have cleared, I think, all the hurdles that there are, except for in Europe. We're still part of the novel food process that we actually started 2 years ago. So it takes quite some time, but we're on the final stretch. So hopefully we have some good news to share in the coming months in terms of, getting also, across that hurdle. So I'm quite confident. Like you said, it's nothing new, right? We're working with barley that has been consumed since 10,000 before BC in different forms of, fashion. So a very ancient and traditional ingredient that we're now giving a second chance, basically as a novel food ingredient.
You're not the only company out there working with brewers' spent grains or some upcycling products such as yeast, for instance. I mean, what makes you guys different?
Yeah, and I get a question quite a bit being part of AB InBev. Obviously, I think at Evergreen, we try to treat it a little different, as in that there's, like you mentioned, a lot of BSG out there on the market, and we want to invite others. So when there's companies in the US, for example, working on processing BSG, we're joining forums with them, we're exchanging ideas. Because I think we would all benefit, together if there's more players, more demand, more offerings on the market that eventually can trigger also consumer demand. So I'm actually excited for everyone that joins into this currently and partners, and we can exchange thoughts, and we're always happy to share learnings as well. We think currently that we have a benefit because we have access to this large scale amount of spent grain that is very consistent. So that's one benefit, of course, is to have a very consistent feedstock that doesn't change all the time. And some of our big brands allow us to have that across the world. That is one of the benefits that we try to capitalize on.
Yeah. And I know you have production facilities. I don't know if this information is out of date, but you have production facilities in the USA and Europe currently. Supply chains are an important consideration for any brand trying to enter the alternative protein space. But I guess with AB InBev backing you can call upon a lot of your existing partners in the value chain.
Yeah, absolutely. And I think our plan is that we have AB InBev has around 250 plus breweries around the globe. And the benefit of working with spent grain is clearly a very local supply chain where you can build a facility very close to where the demand is. So since we're early in the game, we want to use our first facility to test, seed where things work and how in different geographies, and then build out the local supply chains where we can then, like you said, benefit quite a bit from the breweries' established facilities.
Brilliant. Okay, Stefan, we're going to come back to you. We'll move on to Rami now. Rami, from what I understand, you're replicating the way that nature recycles vegetable waste by transforming waste streams into edible mushrooms. I mean, where did the idea for that company come from? And have I got my overall impression of your company right?
Yeah, absolutely. So I moved to Colombia to study microbiology. And here I saw Colombia is number 4 in the world in palm oil production and number 1 in South America. And I was visiting one day a palm oil extraction plant, and I saw that they produce 80 tons of palm husk every day, which is a waste that is very difficult to manage. This is one plant out of 40 in Colombia. So if you do the numbers, that's more or less 1 million tons of palm husk per year just from this produce. Coming back to the question, so I was wondering, how is it possible that an agriculture powerhouse like Colombia, that has such a varied weathers and environment, has 50% of the population below the poverty line, meaning 50% of the people, 24 million people, go to sleep hungry. So at college, I was studying these mushrooms that digest vegetable waste. They go through the wooden components of vegetable waste. And I thought, why don't we use the actual mushrooms that we buy from supermarkets to digest this waste, and neutralizing it on one side, and on the other side, generating this renewable source of, let's put it this way, sustainable source of protein. So that's where the idea initially came from. We actually started selling fresh mushrooms online.
So what are you actually doing now at Phototech?
Yeah, so in order to concentrate the protein, we went back to the concepts and we said, okay, let's take out 90% of the water, of the content of the mushroom, which is water. So now you have 30% protein content. And now we sell a flavor enhancer that reduces sodium in processed foods, all the way from soups, creams, some sauces, and alternative meats, of course. And by doing so, we are achieving to deliver a flavor enhancer in which the protein content is not involved. So at some point when the scales work, very much in line with what Stefan said, we will be able to deliver the protein, in this case, at zero cost.
Could you go into the production process itself in a little bit more detail? I think I read somewhere that your production process is 20 times more efficient than for other proteins. How do you achieve that?
Indeed, certainly. So the protein we obtain from mushrooms is 20 times more productive per hectare if compared to pea protein, which is already twice more efficient than soy protein. These two make up 70 and 17% of the vegan proteins out there in the market. And this is achieved by optimizing the use of the land, which is immediately next to waste, where the waste is generated. Mind you, when we say waste, we mean even domestic and like the residential waste. Like we use any type of vegetable waste for this purpose. And we achieve this also by having reduced considerably the capital expenditures of the equipment that we require to conduct the operation.
Yeah. Could you highlight any of the impacts that your product and process has in terms of CO2 reduction and as well as resource efficiency?
Absolutely. So 1 ton of our produce, I mean, I'm talking about the mushrooms here, avoids the emissions of 19,000 kilograms of CO2, as opposed to soy and pea protein soy and pea as produce that actually produce 250 and 90 kilograms of CO2 each per ton.
Right. Okay. And in terms of optimizing the fermentation process, which I think is a key part of that, what did you have to do?
So our proprietary tech focuses on optimizing the conditions on which the fungi conduct their life cycle in nature. As you mentioned, we certainly imitate nature in the way it recycles vegetable waste when it basically dies, right? And we make it easier for the mushroom to grow in any type of dead vegetable mass, which we usually know as vegetable waste.
And the end product itself, how does that compare against other protein sources such as soy and pea?
So yeah, certainly our protein isolate contains 18 out of 21 amino acids, 8 of which are essential. And our fresh produce contains 30% of protein content, and as mentioned earlier, versus 40% and 20% compared with soy and pea protein respectively. So in this case, soy has a little bit more, pea has a little bit less. But if you add to it the fact that we imitate nature in the way we obtain it, you get that optimized use of the resources that actually is helping nature. As we say, we are eco-positive, not just eco-friendly.
Yeah. I know in our previous discussions, you've cited traceability as an important consideration. I mean, how important should that be for all companies in this space?
Certainly. I mean, I truly believe that in the discussion, we can help each other more, all the companies in the space. And at Phototech, we believe that doing things the right way means, one, advocating for a true circular economy, not just limiting our work to convenient side streams as raw material. In our case, our tech allows it. Two, only giving our consumers products that are free of substances or metabolites, however you like to name them, that happen during fermentation, or even worse, in some cases, parts of the side streams upon which they grow. We do this by using harvested mushrooms. We only harvest the mushrooms from the waste that we utilize. And three, by being able to break down to numbers the impact that we have on 5 different sustainable development goals, and making this information available to anybody who wishes to do the same. Like we've helped some.
Excellent. Okay, I can see lots of questions coming in, so keep those coming in, and I'm going to get to those either at the end or I'm going to weave them in as sensibly as I can. So we're going to come to Natalie now. So at Fly Feed, you're using insect farming, specifically black soldier flies, to convert food waste into proteins for both humans and pets, I understand. So let's address the elephant in the room. Are humans, in the West more so probably than the East, actually willing to consume insects?
It's a very, interesting question. As you said, elephant in the room. But, coming from France, we are actually used to eat lots of very different, very strange stuff, I would say. Snails, frogs, oysters, whatsoever. And actually, it's a question of accommodation. It's a question of cuisine, of gastronomy around it. I don't know whether you have already tested some snails, where they are prepared in France. But for me, it's a challenge to know what actually a snail does taste, because we usually have just the taste of a garlic sauce, which comes with a snail. So basically, I think for the insects, we just need to invent, to imagine this whole cuisine around the protein to make it acceptable for Western consumers.
Now, in terms of your process, I'm guessing the flies are feeding on the waste, and then they're breeding, producing a larvae, and that larvae is processed, ground, extruded, mixed, etc., into an edible protein. I suppose the innovation is not just what you're doing, but how you're doing it. And I believe you're relying a lot on automation in your operations. Is that right?
Yeah, that's completely true. So let's say the insect production used to be something traditional in a seasonal level, mainly in different exotic African or Latin American countries. And now it's for the last 10, 15 years, it goes up industrial. So what allows this industrialization, it all those new technologies that have been developed. So it's automation, it's the Internet of Things, it's all these remote control systems that allows us to work with big amounts of waste to process and with big amounts of larvae to produce.
What sort of applications are you looking at for the end product, the end protein? And when might we see your products available for human consumption?
So for human consumption, let's say in Europe, there is a kind of long road. And you may know that the European regulation actually is divided in three main pieces, depending on whether the protein will be eaten by humans ultimately or not. So when you have the first, I would say, step, which is feeding animals that are not re-entering human food value chain, like pets and fur animals, and this is our primary market. When you have, let's say, a human food value chain, like aquaculture, poultry, pigs, and so on, and it's our secondary market, because here we already have protein meal from black soldier fly, which is an authorized product. And when you have, I would say, the holy grail, which is the authorization to feed humans directly, and where we need to pass through the novel food procedure, which is a very long pathway. But I would say it's also something which is a safeguard also for us usual people. When consumers having our products on the shelf, they are completely reassured that it's completely safe to consume. So it's, I would say, it's long road, but it does worth it.
Yeah. And I understand you've already signed some quite big contracts, about 10 million euros worth, with some European food producers. Is that right?
Yeah, so we have been discussing with several pet food producers here in Europe. So as I said, it's our primary market onto this pet food market in Europe.
Okay. You're currently, the main operation, I think, is in Vietnam. I mean, why is that? Is the government there more supportive of your activities?
There are several reasons for that, I would say. So primarily, Vietnam is a very big country. Actually, it's more than 3,000 kilometers long from north to south. It's about 100 million people living there. And it's a very much agricultural country, actually. Agriculture represents about 15% of its global product income. And what we are working on is the leftovers, the waste of agricultural systems. So, which means that you have lots of raw materials coming there. But another interesting point is about climate. Vietnam is rather close to equator compared to Europe, let's say, and which means that there is very little temperature amplitude between winter and summer. It's less than 10 degrees in Ho Chi Minh in the south of Vietnam, which means that the cost of production, which is in Europe mainly, I would say, emphasized by all these air conditioning systems and so on, it's less impacted by that in Vietnam, just for obvious climatic reasons.
Now, I'm going to move on to this general discussion now. Traditional farming is based on feeding animals with prepared feed for years to produce just a few kilos of meat. So why do we still insist on doing that when those perfectly fine ingredients could be used in human food production to feed millions of people in the first place? So, Natalie, do you want to answer that one? So you're still on screen?
Yeah, why not? So actually, the transformation of, I would say, different types of carbon sources to make it more digestible, I would say it's the main reason. So basically, none of us is able to consume CO2, but actually plants do have the capacity to transform it into proteins. But when you have those plant proteins that sometimes are difficult to digest, so the animals that are consuming plants actually are processing on the next step of processing of it, so which makes it more convenient for us to digest it. So if you look into, let's say, vegetarian animals in nature, for example, like rabbits or sheep or whatsoever, they're actually having very little digestion of what they have consumed. So let's say, for example, rabbit, they usually also consuming their poo. And for example, the sheep in dogs, they're also consuming sheep's poo. So it's kind of the predigestion, I would say, of those proteins. So that's why we're actually working with several transformations, natural transformation of carbon sources.
Okay. And Tyler, I mean, it doesn't seem to make sense to me, but what are your thoughts on that?
Yeah, I mean, obviously, our focus is taking animals out of the supply chain. So we believe it's a really inefficient way to supply food to humans, and has huge climate impact. I calculated about 19% of all greenhouse gases are caused by animal agriculture in the world, or certainly in the U.S. I'm not sure if I haven't checked for the world, but as a result of that, we're investing in companies that are taking animals out of the supply chain to try to make it much more efficient how we use our plant resources.
Yeah. I mean, protein from waste is a big idea. It's one that has the potential, I guess, to revolutionize our food system, but it's going to take the right level of focus of investment. I mean, could I ask each of Rami, Stefan and Natalie about how each of you approached funding and how difficult it was? I mean, Rami, for instance, I know Phototech is part of the ProVeg incubator. Is that right?
Indeed, yes. And in our case, it has taken some time because in Latin America, people are still or let's say institutions are still getting to bet on newer technologies. This is usually a constant in developing economies worldwide, but it is up to us as entrepreneurs to find ways how to bootstrap and to fund until we can take to market our products, and then things get easier, as it has happened.
Natalie, how have you approached funding?
Yeah, I would say funding remains a challenge for our, I would say, deep tech and highly capitalistic companies, because it's hardware. So we need to build factories. We need some physical matters to construct. And it remains a hurdle because it asks for more capital than software solutions. And it has a longer time on investment return than, again, software solutions. So it's still a hurdle. So we really need, I would say, people that are motivated by the ultimate goal of what we are doing, and that they invest in us.
And Stefan, I mean, you're slightly different because you've got the backing of a huge company there, but has that given you the golden ticket?
No, I mean, not at all. And I think we're probably not so different at the end. Like, investment are still, there's competition in large companies as well for where funding goes. And eventually you need to bring a good case. I think for us, it was important to really understand what kind of problem we're solving outside of purely thinking about the sustainability, the circular economy aspect of things. Also, when talking to our customers, yes, it's a driver, but it's not the only driver that will guarantee you a win in the marketplace. So I think it's really important for everyone that wants to, enter into the space or is in the space to really understand, okay, what are the unique properties of my ingredient or my solution that solve a certain problem to a consumer that is not necessarily just, it's more sustainable. Because I think we will have a really hard time. It has to be good on taste. You have to understand the nutritional aspect of your ingredient. It has to look good. It has to taste good, smell good, right? So those are really important aspects. And we spent quite some time finding our niche with this sustainability aspect, which is why I mentioned earlier that, our protein is really good for beverages. And emphasizing that as an attribute. And I think then it helped us to bring that message and that case across to say, okay, we should invest into this because we have a unique property here that is solving a true problem in the market.
Tyler,
Nick, can I just comment on that as well?
Absolutely.
I think one big element that's occurring right now in upcycling, so it's a nascent category. So if you would have thought about all protein's been around 10 years and it's now just started to really come on strong. Upcycling, I first invested in Renewal Mill, I think in 2017. And it was way too early. I mean, there was nothing. Nobody even knew what upcycling was. It's now starting to gain legs. And you saw more of it talked about at Expo West this past year. Whole Foods and Kroger both identified it as key trends for the next, several years in their top 10 list of trends. So it's starting to gain traction. And as a result, then investors will come to the space. But it's still very nascent and very early. So I wouldn't get frustrated that people maybe don't even know what it is yet. It's coming, but in the next 2 to 3 years, you're going to see it as a huge trend.
Yeah. I mean, staying with you, Tyler, it's probably on the same theme. What appetite is there in the VC community today for these sorts of upcycling innovations? And how have you seen the investment landscape change over the past 12 months? It's a very different scenario today than it was, for instance, in 2020.
Yeah, those are two very different questions. But let me first take the investment landscape. Unfortunately, it's probably the worst investment landscape I've seen. I've been in this 20 plus years. And I would say this rivals the dot-com crisis when just VCs all went to the sidelines. Similar thing is happening now. And it's not that they don't have capital, because there's still a lot of capital out there. It's most VCs are worried that there are going to be a lot of down rounds in their current portfolio. And so instead of taking on new investments, they're keeping back dry powder to defend their positions in other investments because they don't want to get heavily diluted in those investments. And we're seeing those down rounds throughout at least the food tech, agriculture space. I think it's happening in tech and other spaces as well. I'm just not as conversant in those areas. With regard to upcycling, it's catching on, but it's still fairly unknown. I'm helping Blue Stripes raise money right now. And a lot of VCs kind of are like, I don't know what that is. I don't know how big that market's going to get. And so they're still wariness. It's going to change because as the grocery chains and end users start wanting to incorporate more upcycled ingredients, the demand is going to grow. And if you think about the hierarchy of food waste, where, as you mentioned, 40% is wasted. What should we do with that food waste? Well, the best thing we can do is to upcycle and use that byproduct into something that humans can eat. That's the top best use. The second best use would then be to feed it to animals or create food through some other source, as fly feed is doing. And then the third use would be to compost it into fertilizer that we can use to grow other crops. The absolute worst thing we can do is let it go down the drain or put it into landfills, because number one, it's just a complete waste of all the climate impacts and that have gone into that food. But then two, it also doesn't degrade. Like an orange takes 15 years to degrade in a landfill. And so it's an absolute waste of something that could have been used in another way.
Yeah.
So I think it's coming, but it's still a ways away for all investors to be interested.
I'm going to take a few questions from the audience now.
Yeah.
Anonymous user asked, if you're going to ask a question, give us your name. That would be fantastic. What are some of the waste or side streams that are still untapped from being upcycled into food ingredients? And then I've got another question later on about the recent Air Protein and ADM announcement or collaboration, and just more general discussion about our proteins. But Natalie, what are some of the other side streams that you think are untapped?
Difficult to say. I would say, again, it's the easiest ones to transform. I think they are kind of already disputed. But when there are still some difficult to transform waste streams, there are also sometimes a difficulty to transport those waste until the factory. So I guess it's one of the concepts that also has been talking about when you need to build your facility close to the waste production. So I think it's also something which is very important in this hardening of waste streams.
Yeah, I would say there's a lot. I mean, it's a massive number. I think I've heard of companies. There's a company in the UK that's upcycling broccoli waste. There's Blue Stripes is upcycling the 70% of a cacao pod that is wasted when they make chocolate. There's 4 or 5 companies that are focused on mycelium. There's probably 10 companies focused on brewer's waste and spent grains. There's what Renewal Mill does is takes all the waste from making soy milk, tofu, and oat milk and creates baking powders and baked goods from that waste. So it's a huge number. It's billions. And so there's huge opportunity if people want to move into this. Think of juices. Every juice, there's pulp that's left over. A lot of that's just fed to animals or thrown away. So there's huge opportunity right now in this space.
I know we had a feature in our... Sorry, go on.
Sorry, I interrupted, but may I add something just answering on that question? For example, in Colombia, flour producers barely utilize the waste from their crops. Like their business is entirely focused on producing the best quality flours and hopefully exporting them, mainly in St. Valentine's Day. And it makes 80% of their yearly business. But coming to the subject, their waste is not being utilized. It's barely utilized to make fertilizer. And very much, as Tyler was mentioning, hopefully we should use these type of waste to make other things like human consumption products, right? So one thing we're doing with a company here is instead of them having to import some coconut shells from the Philippines and Mexico to make a material that they use to grow their flowers, we're developing a biomaterial from which we already extracted our product, our core product, but this biomaterial for them to substitute this import. So that's another example of something that don't go and look into it just because of the business model. Waste from flowers.
Yeah, I know. In our last issue, in the April-May edition, we had an article on waste of proteins, and there are a couple of universities in America looking at recycling plastic into an edible protein. So, yeah, there's lots of potential there. There's lots of potential. I mentioned Air Protein.
Yeah, and the Air one was really interesting as well. Yeah, the Air, there's 2, Air Protein and Solar Foods are both really interesting companies because they're just taking carbon dioxide and oxygen and somehow creating food. Fascinating.
Yeah. I'm coming on to the products, back to the products themselves. I mean, nutrition, we see about the challenges with the alternative proteins all the time. It's taste, it's texture, it's nutrition, it's the aesthetic, it's the cookability, for instance. I mean, from a nutritional aspect, how does the product rate that you're producing, Natalie?
Sorry?
So in the protein that you're producing from your larvae, from a nutritional aspect, how does it measure up?
It has a very nice amino acid profile, and it has very high digestibility and very nice also fatty acid content with many polyunsaturated fatty acids present, so which makes it highly digestible and highly nutritious for humans.
Yeah. And Stefan, it's an important consideration.
Yeah, absolutely. I think on our specific product, we have all the essential amino acids. We're lacking lysine to be a complete protein. But there was also a question on there around P in the Q&A. And I think, especially with plant proteins or generally like the upcycled space, we should always look at complementing factors, right? I think like plants have been able to join forces together and create systems for themselves, habitats to survive well. And I think if we want to take on the animal-related proteins based on complementing a probe, which is a barley protein, together with a pea protein, and getting an improved taste, but also a sustainability fact, as well as amino acid score, that's a great thing to do. So I think that's something we should always consider. Outside of purely amino acids, digestibility or absorption is, of course, extremely important. So we have done a human intervention study with Wageningen lately with our protein, converting it as well to P and whey. And learned lots of interesting things that we're working on publishing in other scientists. So I think that those are kind of studies that are important to really understand the fundamentals of what we're producing.
And I'm going to stay with you, Stefan. We've got a question here from Luke Browning. It's a question for you. Do you have an estimation on the extraction yields of spent grains? Can you share any details on the extraction methodology, such as aqueous extraction followed by precipitation? How competitive are you against P? Well, I don't understand any of that, so I hope you do.
Well, I'll make up my version of it. So on the extraction itself, yes, we have to like solubilize the protein in order to be a spent grain matrix. For us, the protein is very entrenched and entrangled with fibers and the other macronutrients that are still remaining in spent grain. So we do use a water-based enzymatic process to basically solubilize the proteins. The uniqueness about our process is the downstream, and that's also what we patented, is our downstream process, where we use different filtration techniques to eventually produce that kind of like middle section, similar as if you make a whiskey and you cut off the tail and the head, and really that middle part is the perfect product. That's what we do with our protein, because we learned this is the best in taste and the right functionality for our systems. On extraction yield, of course, it's an extremely important consideration, especially when you scale up and you want to be cost competitive. So that's definitely something that we're still working and learning now that we have the first large scale facility. One thing that I can say for sure, I think is like everything that we anticipated from like the small scale or the pilot scale to now running it at large scale is quite different. So we're definitely learning quite a bit on the large scale and still have some room to grow in terms of like getting to like that, closer to 80-90% eventually on extraction yield. So not there yet, but we have some ideas and plans how to get there eventually.
That's great. We have a question here for Natalie as well. It's from San Arsic. If we influence the rearing conditions of black soldier flies to increase chitin, melanin, or lauric acid for potential extraction, how does it influence the flavor profile of the larvae?
Well, it's a very good question. Because only the flavor profile, whereas not only the composition that counts, but also the whole extraction process, the whole processing line behind it. And when discussing, for example, with people from the ingredient company, so they said that actually for them, the most important is that it should be less taste content as possible, because basically they have all the science behind it to add different types of flavors, the different types of taste. I guess it's also something which is partly developed by companies like Givaudan to really introduce this, I would say, familiar tastes in the different new types of ingredients, different types of new alternative proteins.
Okay, I'm going to get back to right. We know that achieving price parity is a big consideration for alternative protein brands. Some are there, others, such as the cultivated meat, are further away. How can your products help companies produce their products more cost effectively, as opposed to sourcing other ingredients? So I'll go to Rami for that one.
Thank you very much. That's a great question. So in our case, we substitute the two main products in the industry that are used right now as a flavor enhancer with a price parity, not necessarily on the kilogram versus kilogram of one product and the other, but rather on the dose, like the amount of product that you need from us to deliver the same result in terms of flavor experience that you used to have with the other two substitutes, but now with the sodium being reduced. So that's how we do it. And the way we actually achieve it is, I mean, nature knows how it does its things. Sodium channels in the taste buds are stimulated by the sodium in those previous flavor enhancers that increase the sodium in our food. In our case, these mushrooms that are very appealing not just to humans but also to other animals in nature, they have this great umami content, but not necessarily connected to sodium, but to other components that are low in sodium. So achieving the sodium reduction in the first place, and then the price parity thing, thanks to our technology that uses any type of vegetable waste on site, reducing other costs, allows us ultimately to deliver the same result, dose versus dose, in economic terms.
And where are you on price parity, Stefan?
I think we're quite competitive to other proteins, but in the similar space. So it's a more premium product, certainly, but it's, like I said, price competitive, I think, to, like, for example, a pea protein isolate.
Natalie?
Yeah, I guess we're competitive as well in terms of the different market which we are targeting. So basically, the price comes from the market.
Okay, I'm just going to go back to the questions from the audience. It's Joaquin Viquez says, it seems like waste is an untapped infinite resource, yet we barely use it for proteins. What are the major barriers for use agriculture byproducts, and how could we go about solving them? He hasn't seen much discussion on availability, collection, transport, heterogeneity, and concrete solutions. So, yeah, who's going to answer that one? Stefan?
Yeah, I mean, I think especially on the heterogeneity, I think that is a big problem, or was a big problem for us in the beginning. Also, when you think about like the early days, we also worked with some of our craft brewers, Spend Grain, for example, where the bill of, recipe just changes on a frequent basis. So I think you're right. I think to make something again at scale, sustainably, long term, something that wins on all the aspects that we talked about in terms of like taste and aroma and everything else, you are required to have a feedstock that is very consistent. And for us, we addressed it and solved it by really scanning all the different element or different types of recipes that we have available, and just focusing on the few that are very similar to each other, where we can say, okay, we can make from these the same kind of like end product. Also, to build in some form of like blending capability throughout your process, where you take some variation in the input material, but throughout that process, you are able to equalize these out. Those are some of the techniques that we have applied and worked through.
Tyler, you're keeping an eye on, oh, sorry, go on. You were going to add to that.
Yeah, I think if you think about demand, we need to educate consumers about what upcycling is. And then ultimately, they're going to see the benefit of it, and they're going to demand those products. And that is going to mean that all the CPG companies are going to want to include those products as ingredients. And that's really what's got to happen, because right now, I don't think that most people are going to get a huge amount of benefit from putting upcycling on the label. Some people will understand it, but not everybody does yet. And once that clicks over and everybody understands what upcycling is and the benefits to climate change, et cetera, then you'll really see a growth of this industry.
Yeah, I mean, that follows on to another question there. Do you have any concerns that shoppers might associate upcycled products made from waste with second-rate products? Rami?
So I'm actually very happy that in the speech of more and more people, it is now incorporated the word upcycling. At the start, it was like Tyler was saying, it was very like frowned upon. And we had to move away from that term for some time just because people wouldn't understand it. But now people appreciate more and more the concept of upcycling. Like that's how I see it. Like in terms of food manufacturers that we work with, they appreciate saying that their food has upcycled ingredients. And I think it's because ultimately consumer knowledge has increased. Like us as individuals, even non-experts in the industry, we appreciate things that are more sustainable.
Natalie?
Yeah, and I would add to that that it's generational too. So if you think about Gen Z, almost every Gen Z knows what upcycling is. They buy upcycled clothes. It's built into their DNA to try to reduce climate change. Baby boomers, not so much. And so, as the consumer population shifts and the buying power is going to be 25% Gen Z in probably 4 or 5 years, then that's definitely going to drive it.
I've got a question here from Paria Samay. Which methods are usually used for protein extraction from waste? What are the main challenges for protein extraction from waste? So I guess that's to Natalie, Rami, and Stefan, and then we'll have to think about wrapping up.
Yeah, just coming a little bit back to this waste upcycling and the leftovers and so on. I think there are different aspects that have to be addressed. There's also a question of safety, because when taking something from waste and put it on your plate, it is always a question of safety that you need to check it for. When, as it's something which has been already used, I would say, in the primer glands, so when it's kind of obvious that people may think that when it's some kind of second usage, so when it's kind of less interesting than what was used in the primary hand. So it's very different questions, I think, that are to be addressed. It's a regulation question, it's educational question, and so on. And in terms of extraction, comes actually tied to with that. It's also a question of being sure about the safety of what we are providing, that we are not extracting everything that we have in the waste, but that we are extracting positively what can be reused and in the best possible way. Because I would say a kind of intoxication with something which has been upcycled would be the worst case scenario for all the upcycling industry, because it will actually damage the image of all of us wherever it happens.
Yeah, I couldn't agree more with you, Natalie, on the safety aspect. I think that's something that does take quite a bit of effort to go through and make sure that we offer 100% good ingredients to the market. On the process itself, I think it's hard to generalize. I think someone, again, going into the space, you really have to think about first, what attributes do you want to achieve in your end product, in your ingredient that you want to upcycle? And then there's, of course, different techniques to choose from. But you couldn't just say, okay, I'm, for example, going for a dry milling process just because it's probably cheaper, it have less yield losses, etc. But in the end, I want a completely fully solubilized protein in water that you will not get to the end target. So important to think about what is it that you want to look at in your final product? What are the characteristics you want to achieve? And then I think there's, very good technologies out there that can help you achieve it. And lots of interesting biotech companies also working in the space that can provide unique solutions from an enzymatic point of view, for example, to it, that they can be applied. So I think there's really open area to work.
Okay. Before we conclude, I just wanted each of Rami, Stefan, and Natalie just to let us know what we can expect from your companies in the future, and then I'll have Tyler just give us an overall assessment of where we can see this particular valorization sector of the alternative proteins industry going. So, Stefan, what can we hope to see from Evergrain in the future?
More exciting products. I think we're also launches where our name is used, upcycled ingredient is used. I think we need much more of it in prominent products. Potentially also launches with more famous people that can be acting as spokesperson for this movement. And then for us as Evergrain specifically, we're looking to create a portfolio, right? Like we want to have not just one ingredient, but multiple ones that can address different applications where we want to be good at.
Natalie?
Yeah, I think it's the portfolio of products had to be expanded so that in the near future there will be some pet products for pets based on the insects, when you will have your preferred salmon or poultry plate that have been with animals that are fed on insects. And ultimately, you have your favorite insect meal.
And Rami?
Well, Ian, first and foremost, thank you very much and your team for the opportunity to be here today with such great colleagues and for this delightful audience. And because it's also an opportunity for me to say that we are franchising our operation in the next 3 years in at least 4 countries. And this is also important for me to say because anybody who's really interested in getting on this sustainability train, we are more than happy to discussing franchising and our outsourced business model with them. So thank you very much.
Thanks, Rami. And Tyler, you've obviously managed the space for the last 5 or 6 years. What do you expect from the space overall in the next 5 to 10 years?
Yeah, well, thank you also for having me. It's been a lot of fun. So when I first started investing, there were probably 10 to 15 companies in upcycling. There's hundreds now. And it's only going to grow. And there's just so many different little categories that are popping up. I would highly recommend it. Plug to the Upcycled Food Association, which was created maybe 3 or 4 years ago. You can find all the companies that are members. and then see the different industries that they're, or categories that they're upcycling. So it's a booming industry. A lot more investment will come in over the next 5 years. So it's a good space to look at.
Yeah, I was literally going to mention the association. You always know it's going somewhere when it's got association. Look, thank you very much. I'd like to thank our speakers today, Natalie, Stefan, Rami, and Tyler. We hope that all of you have enjoyed today's broadcast. You can join us next month on the 28th of June for Building Blocks of a Future System, Advancing Bioreactor Design and Reducing Costs. If you didn't get a chance to ask your question, you can contact the speakers today via this platform or just hook up with them via LinkedIn. And finally, a shameless plug for our magazine, Protein Production Technology International. The April-May 2023 edition is out now and has an article in it on waste to proteins. And we're hard at work on our July-August 2023 edition now, and that will be published on the 26th of July. And within that, we have some wonderful features on alternative cheeses, redesigning bioreactors to reimagine food, supply chain collaboration, and also harmonizing cultivated meat regulations around the world. And our cover story in particular is dedicated to air proteins, so not too dissimilar to today's discussion. So that's it. That's all we've got time for. Thank you very much for joining us, and we'll see you again next month.